Hello, everybody. I promised a bunch of you a blog tutorial kind of thing on how to do the Log4Shell on Kubernetes, and I didn't get it done before Christmas. I'm sorry. What I am going to give to you is a quick video demonstration on how to do it and a link to something that might even be better. Wait to the end for that. So first thing we're going to do to set up your machine is you need Docker Desktop if you're on a Mac or Windows, or Docker CE. I'm going to be doing this on the Docker Desktop for Mac. This should translate to all the other versions. If you have any issues doing it on your setup, send me a message in Twitter or email me, eric.smalling@snyk.io. Whatever, I'll help you out. But I already have Docker Desktop installed and running, and you're going to need I use Homebrew to install things. You're going to need Minikube. And the reason I'm using Minikube instead of Docker Desktop's Kubernetes is because I want to show you something that involves network policy. And the baked-in CNI provider that they use in Docker Desktop doesn't implement network policy. I also am a big fan of Kind, and I'm not using that either because of some complexities when you run that on Docker Desktop as far as getting access to the load balancer and services and things like that. This makes it not quite as simple to demonstrate. So Minikube's a great solution, and it provides a really good way to do this demonstration. So I already have installed that with Homebrew. If you wanted to do the same, you could simply type brew install Minikube. Now I've already done it, so I'm not gonna do it right now. It's already installed. So now we wanna start it up. So we're gonna do a Minikube start, and I want to change out the CNI because I specifically want to have one that I know will work. The auto one might work here, but I know Calico will work, so I'm going to use the Calico CNI. Minikube in the background is going to start up a HyperKit-based virtual machine and set up my kube context to point into the Kubernetes cluster. It starts there, and this will automatically deploy that CNI. I'm not partial to any CNI. Cilium's a great solution as well. So are many others. So choose whichever one you like best. Once that's up and running, we're going to stand up what they call the Minikube tunnel. That will allow any load balancer type services we start inside Minikube to automatically show up as on my local host. Very similar to how Docker Desktop does. It's very nice. So that's done. So I'm going to come over here. And I'm going to run Minikube tunnel, and that will start up. Once that's up and running, we're going to go ahead and get the GitHub repository that you're going to use for this demonstration and clone it down. Let's go ahead and jump over to my browser, and I'll show you where we're going in GitHub. You're going to go to github.com/snyk-labs/java-goof. That's the repository you want to clone. Feel free to fork this, play with it as you want. I'm going to go ahead and hit the clone, use HTTPS or SSH, whatever you're set up for in GitHub. We're going to clone that down. This repository has a couple of things in it that we use this in Snyk for a lot of demonstrations. The apps in here are very vulnerable to things, so just know that. There are a few really quick scripts to get us up and going here, but what we mainly are going to be dealing with is the to-do list. That's the application that's vulnerable, and then the Log4Shell goof has a quick implementation of a fake or faux LDAP server that will serve up the class file for use in the Log4Shell exploit. So now that we have this cloned down, we're going to go into it. And you'll see there's a couple files here that make life easy. Before you run this, make sure you are logged in to your Docker Hub account. If you don't have a Docker Hub account, as written, this demo is going to need you to have one. So pause this, go to hub.docker.com, create an account, get your access key, and then come back here and do a Docker login. Now I'm already logged in, so it's saying you're good. I'm good to go. If you're not, it would have prompted me for my user, which is whatever I set up on Docker Hub, and then the access key that the one-time token that gives you for use here. So once you have your Docker login sorted, come back here and log in. And now we're going to run Kate's quick start. First thing that's going to do is prompt you for your Docker Hub user account name. You can see that it's pre-populating mine. If you set an environmental variable of all caps Docker _account, it'll do that for you. Otherwise, just type it here, either way. And this is going to go, it's going to build the images that we need for this demonstration, push them to your Docker Hub account, and then deploy them into Minikube from that repository. And it should do everything for you. Now it's going to pause right here while it waits for the pods to come up and become active. So I'm going to take that opportunity to come back and try to restart my Minikube tunnel. There we go. That's working now. You have to give this your the password for your system because it's going to bind to low port, so it needs that. And there'll be no more output, I don't believe, from that. So we'll just leave that open in another tab or another window, another shell in the background. And while we wait, there we go. So it built that image, it built the image for the exploit servers, and then it deployed everything out there. And if we want to take a look at what's running, we can do, I have kubectl alias decay, so I'm just too lazy to type. Do kubectl get all, and this will show your default namespace. You can see the deployment for Goof, the pod that it's running, and there's the load balancer service for the Goof app. And you can see that this is what the Minikube tunnel did. It set it up as a localhost external IP. So if we pop back over here and open localhost/to-do list, you should see the front page of our app. Before I do anything with it, I'm going to come back over to my shell. And actually, I'm going to position this on my screen so you can see both at the same time. Okay, so the first thing we want to do is we want to tail the logs of this application. So I'm going to do kubectl logs -f to follow them. And if you have autocomplete set up, you can just tab that in. If you don't, just go get the pod name and paste it in. And there we go. So there's our Catalina log as it sits. So we're going to come in and say sign in. You could go create a user if you wanted to, but the default user for this application is foo@bar.org, and the password is foobar, F-O-O-B-A-R. Go in here and you can see, let me shrink this a little bit, canned set of things. If I type a search field in, we'll get a the. And sure enough, all the things with the come up, and we get a log line spit out that says searching for the. Pretty simple. In the code, we just have a logger. We could put in wash. You'll see that item comes up, and there's the log line down there that says wash. If we put in something like Eric that doesn't appear, again, we get the log, the error. Now, I'm going to put in our new best friend, the JNDI string, JNDI LDAP, ://. In this case, it's LDAP.darkweb. :80, and I'll put this in the video notes so you can copy and paste this. And then the hash symbol or £, and then vandalize. Oops, but type it correctly. There's an N in vandalize. Copy that to use it later. I'm going to hit go. And as soon as I do that, you see this big header has shown up. And no matter where I go in my app, I have this graffiti basically sitting at the top of all my pages. What happened, and you can see the log line, there's that string. What happened was when I sent that down, and I'm not going to go into the details of how this works, too much, but the application interpolated that $curly braced thing, saw that it was a JNDI lookup, found the LDAP.darkweb, which is on my cluster. If I do a git all from the namespace dark web, that's where the evil service is running. The LDAP and evil services are running. LDAP.darkweb returned a reference to evil.darkweb :9999, as you see, port, and that returns the bytecode for a class that rewrites my header JSPF in my app. It could return anything I want it to because it's just running a command on the shell. I could return, it could have gone in and started a crypto miner. It could have pulled down further exploits to get me a shell, some kind of SOCAT based or GoTTY or some kind of terminal in the shell that I could then again start typing away in another window. So the payload could be anything you can imagine it could be. This is just a simple echo into a file. So That being said, let's take a look at what could we do to mitigate this. Now, I'm not going to get into Snyk's tools here because this is more for mitigation, but I would be, telling use Docker scan or Snyk container test, which is the same, those are the same thing, to be scanning your images to find these things. If you're using Snyk's tool, make sure you add the -- app vulns to that tool, and that will do a deeper search into your images and look for the compromised log, the vulnerable log4j jars. The Docker scan automatically is going to do that for you as well. But let's talk about what we could do to head off these things if they were, another 0 day coming down the pike. If we had been using network policy, we could have stopped the Java app from reaching out to that LDAP server. And don't get tied around the axle here about the fact that my LDAP and evil server are running in the same cluster. I did that for simplicity so that I could deploy it quickly and I could have a separate DNS lookup for it using that dark web domain. That could very easily be running at, ericsmalling.com, LDAP, whatever. Yeah, running out there on the internet, totally in another network. And it wouldn't matter. The fact that it's in cluster is irrelevant, really. But what you should be doing is you should be making sure your pods aren't talking to things they're not supposed to talk to. And you can do that with network policies. Before I go any farther, I'm going to delete my goof pod so that Kubernetes will spin up a new one that doesn't have the hack applied. And let's go into, now we're in that Java goof repository. I'm going to dig down a little bit. There is a to-do app, to-do list.-goof directory. And under that, there's a K8s directory that has all the scripts. That quick start script called all of this stuff to set things up. In here, I'm going to show you noegress.yaml. If you've not looked at Kubernetes network policy before, this is a fairly simple one. What this says is it instructs the CNI provider to implement basically firewalls. And these firewalls are based on selectors. So you can say, hey, make an ingress or egress rule that applies to the namespace I'm putting this in. Any pod that matches, or any object that matches a label selector, say app equals this or whatever, and then apply certain rules to it, allow list type rules. In this case, my pod selector is the empty set, and that is saying all pods, I'm going to deploy this to the default namespace. So all pods in the default namespace get this policy, and this policy defines an egress policy. It leaves ingress alone, and that egress policy is only let traffic out on port 53 UDP or TCP DNS, which you need to allow, because if you don't allow that, then service lookup doesn't work at all. But let's go ahead and apply this. And it's called no egress. So I'm going to apply -f no egress, and it is out there running. And let's start another log tailing. There we go. And let's go back. Now I like to do this. You could try to click this. Cookies will sometimes screw up if you don't do this. Go back to localhost /to-do list. Then sign in, re-sign in, since we restarted the server. There's no state in this thing. And let's just make sure it's still working. That worked. I should still have in my paste buffer this string. If not, copy it from the YouTube comments or the YouTube description. I'm gonna hit go. And now you'll notice the spinner up here, if you can see that, it's just spinning. So we've got a thread that's hung in Tomcat right now. And what happened is the same interpolation happened. It's trying to do the JNDI lookup, but because we're still vulnerable. But because I have blocked all egress traffic out of all of my pods in this cluster, including this one, it was able to do the DNS lookup on that, but now it's trying to open a socket to that IP. And it's just blocking because the CNI provider has configured the cluster to say, no, pods, you can't talk to that. Now, in real world scenarios, you obviously would have much more granularly defined network policies. You would have things like, connect to front end can connect to back end on these selectors, or ingress can come from front end on these selectors, or database can be connected to that. All of those kinds of connections you'd lay out for your application, and you'd specify it by label name. And the beauty of network policy is that no matter where Kubernetes schedules the pods across all of the nodes, it doesn't matter. It understands the selectors. So you could have 5 replicas of your front end, 3 of your middle tier, and 2 databases, and they could be spread across randomly. You don't even care where they are. CNI will take care of saying, pod with selector this is only allowed to talk to the middle tiers and on TCP 8000 or something, and it'll let that happen, and the round tripping will automatically be taken care of. Or you could say, hey, database tier can only be connected to pods that are in a namespace labeled this, so you could have a middle tier namespace and only pods that ran in there can connect. It's all sorts of options you can do here, and this is just standard network policy. This isn't even getting into any fancy things that Calico, Cilium, Antria, all these CNIs might provide on top of that. So network policy is your friend. As a developer, when I first saw it, I thought, oh, networking, it's complicated. It's really not. Just learn how to use it, and it's a great tool. So that's one thing you could do to mitigate. So again, not a silver bullet. It's still locking up a thread. There, it just timed out. It's still locking up a thread, which is not good because you could still get denial of service if they machine gun you with this. But it at least stops the main vector of attack for this remote code execution and gives you a little bit of breathing room while you figure out where all you need to patch your apps, right? There's a couple other things you could do. Let's say you didn't want to do network policy, or for whatever reason it wasn't an option. Let's delete -F, no egress. So we're going to get rid of that network policy. So we're back in a vulnerable state. Okay, so let me show you what I deployed. And I'm going to talk about a couple other mitigations. I'm not going to go through them because they're kind of simple, but and I'll leave that for your exercise later. Here's what we deployed originally. You can see it's very basic, just starts up the deployment and sets replicas to 1, and then below there's a service. If I type this correctly, there we go. If we were to add a security context, let's say we couldn't do that network thing. We could add a security context that says don't run as root. In fact, run as the nobody user, which that happens to be the UID, GID in the Tomcat image for that. This would prevent the user that the service is running on, and thus any remote code execution processes it spawns, from making any modifications to the file system. Do note that in this demonstration, if you go try this, you're going to have to up the Tomcat version in the Docker file and rebuild that image, because the version we're at doesn't support this. So I'm not going to demonstrate this right now. This is really a good idea anyway to not be root, because even if you're in a container, root has elevated privileges and can do things that it shouldn't be able to, and can edit files in the container file system. Not a good thing. The other thing you could do, which is if let's say you can't be root, or you have to be root. Sorry, you can't do this for some reason. Like you need to stay on the older version of Tomcat that this won't work with. Run with a read-only root file system. So this version has a security context where I set read-only root file system to true, which tells the container runtime engine, .containerd or Docker or whatever, to not implement a read-write file layer. So immutable file system, read-only, always a good thing. Now, Tomcat needs some mutability. So out of the box, it's going to need a temp directory, a work directory, and a logs directory in order to dump those kinds of the files it's constantly writing to the file system. So we're using emptydir for this, which is the transient tempdir, temp file system based setup that is ephemeral. As soon as this pod dies, those go away and new ones are started up for, makes it quasi-immutable, right? Again, this is just like the network piece. This isn't a silver bullet either, but it would prevent this exploit where we're modifying and messing with the files in the image from happening. These things all combined, we always talk about defense in depth. Having network policy rules, egress and ingress rules, all set up in concert with other things like this make life harder for your hacker. You should also minimize your image size. Don't include tools in your image that a remote code execution exploit can leverage, such as curl. Curl is in Tomcat. Shouldn't be. You don't need, unless you need curl for your app, don't give it to the hacker to use against you. I believe that the Tomcat version -slim tags don't have curl, so you should probably use one of those or some other image. Anyway, I've been going on and on. This has gotten longer than I expected it to. So let me wrap up by saying if you want some more resources on dealing with Log4Shell, not to pitch our stuff, but if you go to snyk.io, we have put together a pretty nice page. If right at the top, that banner that says resources, click here, and we have a collection of things, all sorts of entries and blogs and webinars and videos that our team has been doing, as well as a few things right here at the top. There is a Log4Shell remediation cheat sheet. This gets into the lower level, beyond containers, down into the Java side, and walks you through some really good advice on how to find and fix this problem in your Java apps. I'm not going to go through all of them, but they go into fixing the dependency, finding the dependencies, whether in your transitive dependencies or otherwise, or direct, fixing the version, hacking if you need to, if you can't change your version, how to rip out the classes that actually implement this. It's not the best way to do it, but it is another way to do it, and other things, including some information about WAFs. That a WAF is great for trying to catch these strings as they come in. Then it's not foolproof though. So the next thing on here is this GitHub awesome list. So out on GitHub, we have started an awesome list in our Snyk Labs group. You can come in, there's tons of stuff in here that we and other people from the community have added. If you've got something that you don't see here that you think is good, open a pull request. Our team will look at it and we'll get it added if it meets a qualification. And then finally, you back up. There is a lesson we've added. Now, this is what I talked about at the beginning. So I don't have my tutorial done because this has been crazy this past week. But this is a tutorial that is pretty cool. It walks you through a whole hack implementation. It dives in, it's got diagrams. The Learn team has done a great job really walking through here. And I highly recommend you take a look at this. And I'll tweet this out as well. And it'll be in the description below. Finally, the last little piece of information I will throw out is we also have a cheat sheet that my colleague Matt and I wrote back in March that goes through security context settings. I talked about a couple of security contexts here. You should be implementing these, and this cheat sheet will walk you through 10 of the most common, well, there's only like 12, but the 10 very common ones, what they are, and how you can use them to make life harder on hackers. So that being said, thank you so much. It is December 22nd as I record this, so no matter when you're watching, I hope you have a wonderful holiday time. Hope you have some time off with your family and friends. Happy New Year, and I'll see you in 2022. I almost forgot. When you're all done, you should clean this up because Minikube is still running there in a VM on your machine. So type Minikube delete, and that will blow it all away, and it'll be like it never happened. And then if you want to clean up the the GitHub repo you checked out, you can delete that, or you can keep it and play with it as you will. There's a bunch of cool stuff in there. You can take a look at other vulnerabilities we've seen in Java apps. Ciao.